Hello everyone. In today's video, we will talk about the car radiator. We will find out what a car radiator is, its function in a car, and the symptoms of a bad car radiator on your car engine. But before we continue, please hit the subscription button and turn on the notification bell so that you will be the first to see my video once it drops. A car radiator is a crucial component of the vehicle's cooling system. It helps regulate the engine's temperature by dissipating excess heat generated during operation. The radiator consists of a series of thin tubes and fins through which coolant flows. Here's how it works. Number 1. Coolant circulation. Coolant absorbs heat from the engine and circulates through the radiator. Number 2. Heat dissipation. As the coolant passes through the thin tubes in the radiator, the heat is transferred to the fins. Number 3. Airflow. Air flows over the fins, usually driven by a fan or the car's forward motion, which cools the fins and, in turn, the coolant. Number 4. Cooled coolant. The now cooled coolant is recirculated back to the engine to absorb more heat. By maintaining the engine at an optimal temperature, the radiator prevents overheating, ensuring the engine runs smoothly and efficiently. Having learned what a car radiator is, let us discuss the primary functions of a car radiator in your car engine. The radiator in a car engine serves several essential functions to ensure the engine operates within its optimal temperature range. Here's a detailed explanation of its functions. Heat dissipation in a car radiator. Under heat dissipation, we have the primary functions and the process, and they are number 1. Heat absorption. The radiator's primary function is to dissipate the heat absorbed by the coolant from the engine. As the engine operates, it generates significant heat due to fuel combustion and friction. This heat needs to be managed to prevent engine damage. Number 2. Heat transfer. The radiator facilitates the transfer of this heat from the coolant to the surrounding air. The radiator is designed with numerous thin tubes and fins to maximize the surface area for efficient heat exchange. Number 3. Heat release. By dissipating the absorbed heat, the radiator ensures that the coolant is cooled down before it circulates back to the engine, maintaining its optimal operating temperature. The process entails how the coolant flows. It circulates through the engine, absorbing heat as it moves through the engine block and cylinder head. This heated coolant then travels through the hoses to the radiator. Number 2. Heat exchange in radiator. Inside the radiator, the coolant flows through a network of thin tubes. The large surface area of the tubes and fins allows the heat to transfer from the coolant to the radiator's metal. Number 3. Airflow and cooling. Air flows over the radiator fins, either through the vehicle's movement or with the aid of cooling fans. This airflow removes heat from the radiator fins, cooling the coolant. The cooled coolant is then pumped back into the engine to absorb more heat, completing the cycle. This continuous process ensures the engine remains within a safe temperature range, preventing overheating and maintaining efficient engine performance. The next point we will discuss is maintaining optimal engine temperature. Let us start with temperature regulation. Number 1. Thermostat control. The cooling system includes a thermostat that monitors the engine's temperature. When the engine reaches a certain temperature, typically around 195 degrees Fahrenheit or 90 degrees Celsius, the thermostat opens, allowing coolant to flow into the radiator. Number 2. Coolant flow regulation. The thermostat regulates the coolant flow based on engine temperature. When the engine is cold, the thermostat remains closed, directing coolant circulation primarily within the engine to aid in warm-up. As the engine warms up, the thermostat gradually opens, allowing coolant to flow through the radiator for cooling. Number 3. Maintaining optimal range. The thermostat's function ensures that the engine operates within its optimal temperature range. This range is critical for engine efficiency, emissions control, and longevity. If the engine temperature drops too low or rises too high, the thermostat adjusts the coolant flow to bring it back to the optimal range. The cooling cycle. Number 1. Coolant circulation. The cooling cycle begins with coolant circulating through the engine, absorbing heat generated by combustion and friction. The coolant absorbs this heat and carries it away from critical engine components. Number 2. Air cooling. airflow over the radiator, either through the vehicle's movement or electric fans, carries heat away from the radiator's fins. This process cools the coolant inside the radiator, lowering its temperature. These processes work together to maintain the engine's temperature within the optimal range, ensuring efficient combustion, reducing emissions, and preserving the longevity of engine components. Effective temperature regulation and a well-functioning cooling cycle are essential for the overall performance and reliability of the vehicle. The next function of a radiator is to prevent engine overheating. Number 1. Design of radiator. The radiator has numerous thin tubes and metal fins, providing a large surface area for heat transfer. This design maximizes the contact area between the hot coolant and the cooler air, allowing for more efficient heat dissipation. The efficiency of this heat exchange is crucial in preventing the coolant from retaining too much heat and subsequently overheating the engine. Number 2. Material choice. Radiators are typically made from materials with high thermal conductivity, such as aluminium or copper. These materials efficiently transfer heat from the coolant to the air, ensuring that the heat absorbed from the engine is quickly and effectively dissipated. This rapid heat transfer helps maintain a stable engine temperature and prevents overheating. The airflow. Number 1. Vehicle movement. As the vehicle moves, air naturally flows through the grille and across the radiator's surface. This airflow removes heat from the radiator fins, enhancing the cooling process. The faster the vehicle moves, the more air flows through the radiator, increasing the heat dissipation rate and helping to keep the engine temperature in check. Number 2. Cooling fans. When the vehicle is stationary or moving slowly, electric or mechanical cooling fans provide additional airflow over the radiator. These fans are controlled by the engine's temperature sensors and activate when needed to ensure continuous air movement across the radiator fins. This consistent airflow is vital for maintaining cooling efficiency, especially during idle or low-speed conditions, preventing the engine from overheating. These aspects of heat exchange efficiency and airflow work together to ensure that the engine remains within its optimal temperature range, effectively preventing overheating and maintaining reliable engine performance. We will now discuss the symptoms of a bad radiator in a car engine. A bad radiator can cause several symptoms that indicate potential problems with the car's engine cooling system. Here are common symptoms to look out for. Number 1. Overheating. The most obvious symptom is engine overheating. If the radiator is not functioning properly, it cannot effectively dissipate heat from the coolant. This can lead to the engine temperature rising above normal levels, which may trigger warning lights on the dashboard or cause the engine to overheat and possibly shut down. Number 2. Coolant leaks. A leaking radiator can result in coolant dripping or pooling underneath the vehicle. You may notice puddles of coolant when the car is parked. Coolant leaks can occur from cracks in the radiator tank, damaged hoses, or corroded fittings. Loss of coolant can lead to overheating and potential engine damage if not addressed promptly. Number 3. Low coolant levels. If you frequently find yourself needing to top up the coolant reservoir or notice the coolant level dropping without any visible leaks, it could indicate a problem with the radiator. A faulty radiator cap or internal leaks within the radiator could cause coolant to escape, leading to low coolant levels. Number 4. Visible damage. Inspect the radiator visually for any signs of physical damage, such as cracks, corrosion, or bent fins. Damage to the radiator structure can impair its ability to cool the coolant efficiently. Number 5. Engine misfire or poor performance. In severe cases of overheating or coolant loss, the engine may experience misfires, reduced power, or poor acceleration. This occurs when the engine's operating temperature becomes too high, affecting combustion efficiency and overall engine performance. If you notice any of these symptoms, it's important to have the radiator and cooling system inspected and repaired by a qualified mechanic. Ignoring radiator issues can lead to costly engine damage and potentially unsafe driving conditions. So, there you have it. If you like my video, please hit the subscription button and turn on the notification bell to get my video when it drops. Thank you.